Have you ever looked up at the sky and watched a plane glide effortlessly above, wondering how something so heavy can defy gravity? It seems almost magical, like a giant metal bird, but the truth lies in science and the clever use of physics. To understand how airplanes fly, we need to break down the forces at play. There are four main forces that affect an airplane in flight: lift, weight, thrust, and drag. Lift is the force that pushes the airplane upward. It is created by the wings, which are specially shaped to generate this force. The shape of an airplane wing, called an airfoil, is curved on the top and flatter on the bottom. As the airplane moves forward, air flows over and under the wings. According to Bernoulli's principle, faster-moving air has lower pressure. Since the air moving over the curved top of the wing travels faster than the air beneath it, the pressure on top becomes lower than the pressure underneath. This difference in pressure pushes the wing and the airplane upward. But lift alone isn't enough to make a plane fly. The airplane must also overcome weight, which is the force of gravity pulling it down. To counteract weight, the airplane's engines produce thrust. Thrust moves the airplane forward, pulling it through the air. Jet engines, for example, work by sucking in air, mixing it with fuel, and igniting it. This creates a powerful explosion that pushes the airplane forward. The faster the plane moves, the more air flows over the wings, and the greater the lift becomes. At the same time, there is drag, which is the resistance an airplane faces as it moves through the air. Think about when you put your hand out of a car window while it's moving. You feel the air pushing against your hand. That's drag. Engineers design airplanes to be as sleek and aerodynamic as possible to reduce drag so the plane can fly efficiently. For an airplane to take off, thrust has to be greater than drag and lift has to be greater than weight. When the plane races down the runway, the engines build up enough thrust to push the plane forward at high speed. As the speed increases, the wings generate more and more lift until it overcomes gravity, and the plane lifts off the ground. Once in the air, pilots use a combination of controls to keep the airplane steady and change its direction. The ailerons, located on the wings, help the plane roll from side to side. The rudder on the tail helps steer left and right, and the elevators, also on the tail, control the plane's pitch, whether it goes up or down. By carefully adjusting these controls, a pilot can navigate the plane through the sky. When it's time to land, the process works in reverse. Pilots reduce thrust, which lowers speed and decreases lift. Flaps on the wings extend to create more drag, slowing the plane down further. Eventually, weight overcomes lift, and the plane gently descends onto the runway. So the next time you watch an airplane cut through the sky, ask yourself, what invisible forces are at work, making this incredible journey possible? It's a delicate balance of lift, weight, thrust, and drag, all working together. What seems like a simple flight from one city to another is actually a masterpiece of science and engineering, proving that humans have found a way to conquer the skies through understanding the laws of physics.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.